Yeah, so this time I'm going to talk about Dr. Pat Bowen's project. A similar situation, they started and they retired, and I took over their project. Okay. So overall, her project is also pretty straightforward. So she wants to provide some like useful management tools. So the first one is the GIS system, and it's a always ongoing thing. We're always trying to update this database and trying to improve the data structure also. And the second part, we go back to the irrigation trial, but this time, second portion of irrigation, we are not only answer Simone's question, but also we will demonstrate how we use the remote sensing technology to spot the water stressed vines in a vineyard. And the last part, the other utility for the of the remote sensing, we're going to demonstrate how to use that remote sensing technology to spot virus vine. Yeah, so that's I think our audience was pretty interested in that, right? Okay. Okay, so the first one, and this is the update and modernize the viticulture JS database and the vineyard map inventory. So my technician, I think he's probably here, Steve Marsh, and I bet he's the one person in BC like work on most of the vineyard here. So he's the one actually walking into those vineyard block and mapping the area, the whole area of that block, and also capture all these different index or factors. Like usually just the basic units is a one vineyard block, and we register or recording those like a topography and a variety, all these factors, cultural practices, all those stuff in that database. So you can imagine how many vineyard blocks are in the BC. That's tons of them, and we kind of accumulate so many data, but a lot of them were not digitalized. So in the past few years, and we actually finally enter all those backlogged data. And Brett, the other technician, he also improved the data structure of the older version. Now we are in the newer version. But as you know, the whole industry suffering from that the cold events. So we're expecting lots of variety change. So like it's probably another big change coming really soon. For this database, we need to update everything again. Yeah, and the other main focus of this objective is actually Pat want to know the soils factor in these different locations. So she picked like 20 sites across the valley and took the soil samples, measures so many different soil characteristics, like a soil carbon content. And over here, I will mention about one of the her major findings, and basically echoes what Maddie said in the morning. So the first thing, we have the database, right? And now we have the soil carbon data. We want to see if there's any correlation between the soil carbon content and with all those other factors in a database. So in the end, we didn't really find much association between the soil carbon with the cultural practices, but we did find a correlation with the soil texture. So like how we sample the soil is from 20 sites, and we separate the soil samples from the under vines and the soil samples in the valley, and we took out two depths. So like a 0 to 15, the shallow one, and the one deeper one. And overall, the soil carbon content in the valley is fairly low. It's the maximum is only at 4.3%, and the lower side is 0.3%. And over here, these three graph shows the correlation And you can also notice the R square is fairly low. What is R square means? R square means how much variation could be explained by the value in the x-axis, and the rest of the variation come from somewhere else. So, for example, over here, the clay content can only explain the 10%, approximate 10% of the variation here, and the rest of them come from somewhere. And our database actually didn't really capture those variation. Okay, and overall, the trains are pretty straightforward. Once you have a higher clay content, the soil carbon content will be higher. Same apply to the silt percentage, but the sand content is opposite. If you have a more sandy soil, usually you got a really, really low soil carbon content here. And the other thing you can notice is how the data points spread here. I think these also kind of like a means how easy you can accumulate the soil carbon content in the soil. But I'm not an expert in in the soil science, so maybe it's better to reach out to our soil scientists like Kirsten or Maddie for the really detailed answer. And the other thing I did kind of like play around with the data. I draw the range, like where our soil is. So basically in the soil texture triangle, the whole valley actually just occupied this corner of this triangle. The higher clay amount is 23%. And the silt is 44, but in some cases, the sand portion is super high. It could go to like a 96%, which is, to me, I said, wow, that's just like a sandy beach, right? Okay, so the other thing is overall it's very low, so I kind of trying to visualize the soil content, and with those three graphs. I actually translate that into kind of like the color or the gray color scale. And basically, there's a differences. There's a variation inside this area, but we actually couldn't really distinguish it. That basically means the overall soil carbon variation is very little in our condition, right? Okay. So basically, what the result shows soil texture matters, but there is something else we didn't capture, right? The culture practice probably still be very important, but there's no correlation found, as I mentioned before. That's probably because of how we capture those factors is not really efficient to identify what's the cause. For example, like we usually capture the qualitative data. So for example, are we using drip lines? But to soil carbon, that's probably doesn't matter. That's insufficient to achieve our goal. So to improve these database, probably we have to think about how to capture more quantitative data. So in the future, we can do better regression analysis. Okay, now move on to the irrigation sector again. So now basically over here, I look at the result. Like one question I want to ask is, could we use less water, just like Hans always ask, right? And over here, and also this graph kind of like probably answer Simone's question. So this is the stress level we reached at a certain measurement point. So on the y-axis, that's the photosynthesis rate. And over here, that's the conventional rate. And once you reduce the irrigation amount, you also reduce the photosynthesis rate. But over here in these red box, actually, even though you reduce it to 67%, but there's no significant if you compare these two treatments. But if down to 50%, that will show the differences between the 50% and 100%. So basically, over here, slightly reduced rate probably doesn't hurt, but there is the regression relation over here. That also means you should be able to adjust these photosynthesis or stress level just by doing regulate the irrigation amount. And you see here that the R square is very high, which means you can definitely have that control over photosynthesis or the stress level just by irrigation amount. And also later, I will in the next few slides, I'll explain that. And there are room actually using irrigation to adjust the juice and the yield component. So over here, that's the yield component. And also, there is a correlation established here. Same thing as less water you irrigate, and you will kind of slightly reduce the yield. But same thing, if you just reduce to 67%, it doesn't really have a significant differences compared to the regular conventional practices. Okay, so the question I asked over here is, could we adjust, for example, here is a yield by irrigation? I think the answer is yes. But on the other hand, could you use irrigation to adjust one of the yield component, which is the cluster number per vine? The answer is no. So sometimes you will see this relation. I didn't show all the yield components here. But yeah, so this is kind of how I analyze this data. And regarding the juice composition, I think you could actually use the irrigation to adjust, for example, the pH. If you will irrigate, the pH is usually lower. And also over here, the same thing for the titratable acidity. You can also doing the manipulation by adjusting the irrigation amount. But also here, actually, the pH, increase the pH actually give you another hint. There might have some severe water stress event happen. So that's when the leaf fall, they want to recycle those nutrition from the leaves, right? So there's tons of, for example, potassium during the verizon time. So where are those potassium go? They go to the sink, which is the berries. So the potassium will actually force the proton out of the berry. So that's probably the reason why we're seeing the pH increase. Ooh, 3 minutes, I think it's good. Okay, so here is the RGB remote sensing type of data here or like observation. And actually we did see like a really yellow and leaf fall, the yellowing and the leaf fall over the basal shoots, basal nodes. So this is kind of like a stress level we got. And over here, that shows the NDVI. We use the drone to image to capture the NDVI factors, just like Kevin's data, right? You could we actually use the point clouds to dissect. So if with that data, you can actually dissect the canopy. We separate the canopy into 3 sectors, but also you can only see NDVI only shows more differences in the lower canopy side. Okay, so the irrigation treatment actually affect the NDVI at a different height, and anyway, it's actually not sufficient to make a irrigation decision. It won't recover, right? After even though you recover the irrigation, now it's well irrigated, but the damage already been there, and your NDVI still capture the old water stress event. And basically, the response is too low, too slow. It's really hard to use NDVI to make the irrigation decision. But the infrared sensor is actually really good because when the grapevine suffer from water stress, they close the stomata, and with cell transpiration, the canopy temperature increase. Okay, just like this graph shows here. in the same time, even the canopy temperature actually correlated to the photosynthesis. Okay, so basically you can combine these sensors using the canopy temperature to kind of estimate what's the photosynthesis rate in a vineyard. And so we can actually, for example, depends on your purpose. Over here, we actually arbitrarily trying to separate the canopy temperature into 3 sectors. And with that, you can actually evaluate what's your vineyard spatial variation easily. And maybe you want to use some other irrigation management to kind of like correct those uneven events. So this is how we could use the infrared remote sensing technology. And over here, this is a start of like about how we train the model from the remote sensing data and to create a model trying to predict if or to estimate how many vines are being infected by virus. So basically what we did is we have input indexes, just like Kevin said, there are tons of many indices, right? And we capture all different wavelengths and throw them into this is a neural network model. So it eventually it will kind of like form the model and will tell you if these vines are infected by virus or not. So we have in one vineyard, we have 70% of the vines are for training and the rest of the vines are for validation. Okay, but the disadvantage of this method is actually we couldn't identify what's the mechanism, what's the relation between all these index, because the relation just couldn't be figured out if we're using this method. So over here, this is the result. Like this is a kind of demonstration. We use this technology trying to, okay, these red dots are predicted virus infected vine. Okay, so but there's something we found like it's not necessarily true. We have to still this is a model. We need to validate this model, right? So we found a further validation is required, but at least this is a kind of like the start of this usage. Yeah. Okay, and I think that because of time. Yeah, so let's go to the take home here. So basically, the soil carbon is super low in the valley, and the soil texture matters. And reducing the irrigation amount from 100% to 67% probably will not compromise your yield, but in the same time, you might be able to adjust the juice composition. And the RGB and NDVI could capture those yellowing leaves. So these post water stress symptom, but it doesn't really capture the real time. But the infrared remote sensing technology could do that job really well. And yeah, so in the end, looks like the remote sensing technology through the building the model, you can kind of give you a hint where are those virus infected vines are. Okay, that's all the talk. Thank you.